Okay. Weeks one, the word of the week for week one was algorithms. The word of the week for week two is variables. So today we're going to talk a lot about variables. I'm going to have another couple videos after this, but this should be the first one. I'm sorry it's taken so long for this one. I had some computer problems among other things, but I think you'll be fine. You'll have plenty of time to do the things you need to do. It just means I'm a little bit behind what I want it to be. So variables today. Specifically today, we're going to do a little bit more than that. We're going to look at four different types of statements in kind of a little mini programming language that we're going to use just for this week. In this week, we're going to have variable declarations, put statements, input statements, and output statements. Now, this is just for this week. Next week, we're going to move on and use flowcharts. But most of what we're doing this week will be carried over into next week and through the whole semester. Variable declarations and input and output statements will be. Now, put statements are just for this week. By next week, we're already going to be replacing them with assignment statements, and the put statement will become obsolete. But for various reasons, it is a little bit more helpful, and people usually do better in the course if I start with put statements this first week. So this is our little miniature language. Assignment 2 will give me answers in terms of these four things. No flowcharts yet, just these four things. So I need to explain how they work and what they are. And what I'm going to focus on in this particular lecture is the first two, the variable declarations and the put statements. Okay. By the way, for each of these, they're not in the book, although they're very close to what's in the book. So I have provided in Canvas in the documents, there's specific documents talking about the rules for each of these things: variables, put statements, and input and output statements. And those documents are the key. What I mean is they have the authority. So if you do something the way those documents say you should, you'll be fine. Even if I took off points for it, I'll give them back to you as long as the algorithm is correct. But if you do something that they say you shouldn't, then even if I forgot to mention it, you still lose points. So you're responsible to stick to the rules that those Canvas documents say. But I'm pretty much going to follow them here as I go too. All right, let's start with a sample program. Very, very simple program, not all that useful. What it's going to do is the following. When you run it, first thing it's going to show you is nothing at all. It's just going to sit there with the cursor blinking. And you're just supposed to know, because this isn't a very good program, you're supposed to just know what you're supposed to do. And what you're supposed to do is type in an item that you want to purchase and what its price is and how many you're purchasing. So if you're purchasing milk at $2.25 a gallon and you're purchasing 2 gallons, you're supposed to type that in. So that's typed in by the user, and then the computer will respond by typing out a $4.78, which is how much it will cost you. So the user types these on the keyboard, and the computer types this, outputs this on the monitor. It takes 225 times 2 to get 450, adds in a 6.3% sales tax, and then adds that into the 450 to get 478, and that's what it prints out. Okay, so this is the program we want to think about. And the program itself, using our little miniature language, looks like this. On the left-hand side, we have what is called a set of variable declarations. We have the word variables underlined at the top, and then a whole bunch of variable declarations, individual variable declarations underneath it. I'm going to talk more about these later on, but you can see it always starts with the word string or num in this case, and then it always has a name after that of a variable: item, price, amount, subtotal, tax rate, and so on. And in the case of tax rate, we have an equal sign and then a number, 0.063. We'll talk about what all that is. On the right-hand side is the rest of the program apart from the variable declarations. And you're going to give me all semester variable declarations separately from the program. And on the right-hand side, we have a program with input item, input price, input amount. So we have 3 input statements and then 3 put statements and then an output statement. And so these are the 4 pieces you'll need for every program in this section of the course just this week, this week's worth of variables and input, output, and put statements. Okay. Let's talk about how a program works by using this example and by talking about what a computer looks like. Now, from the point of view of a programmer, this is the picture of a computer that we care about. In other words, we don't care about the details of how it's engineered. We don't care what's inside on the chips inside. We don't care how big or how small it is, or what brand it is, or what operating system it uses. All we care about is the things that are essential to every single computer, and that's the 4 things that are here. First of all, you have to have, for any computer to be useful, in addition to the computer proper, you have to have at least one input device and at least one output device. So the input device I've drawn or inserted on the left over here is a picture of a keyboard. So we're going to consider all semester that our input device is the keyboard. We're going to assume users type things in on the keyboard. But of course, there's other kinds of input devices too. There's a mouse, and there are microphones and things like that, and cameras, and all those things can be input devices. So we're just using the keyboard here, but imagine that you had any input device you needed to. Somehow or other, though, there has to be a way to get input into the computer so it knows what it's working on. Also, every computer system will need some sort of output device. I've drawn or inserted a picture of a monitor over there, but you can also think of a printer or even speakers or things like that. So there'll have to be some sort of output device so the computer can actually tell the outside world what it's found. And then the main thing is inside the case itself, whether you've got a mainframe or whether you've got a smartphone or whether you've got, a computerized chip on an oil rig or whatever you've got, there's going to be in some sense or other the two pieces that I've shown in the middle, memory and central processing unit. Memory is really critical to what we're looking at today. That's where all the variables are. So memory is basically the scratch paper of the computer. As the computer calculates, it needs to hold on to temporary results. It will store them in memory. There are different kinds of memory. Mainly what we're talking about today is what's known as RAM. And you can actually buy chips and put them into your computer to increase how much RAM you have. But somehow or other, your computer's got to have some sort of memory. There's other kinds of memory it can use as well. But it's got to have some sort of memory or it really can't function as a computer. And the central processing unit is just the whole collection of whatever it takes to really run as a computer, in addition to memory. Usually there is a processor, some sort of central processor, sometimes a collection of processors, which sort of controls the programs. That is, it keeps track of what line of each program it's on and then when to go back to the next one and when to go back to the next one, sort of orders the sequence. But then there's also something called the ALU, or arithmetic logic unit, which does the operations that computers do. And primarily, arithmetic means it does plus, minus, times, divide, and logic means it does less than, greater than, less than or equal, not equal, and equal. It does comparisons. And there's very little else it does besides those two things. And basically that's what computers are made of, something to move things around in memory based on plus, minus, times, divide, and comparisons. All right, so how does that work in the example we had? Well, we had a program that started with these variable declarations. So what that means is that that the program will begin by setting aside specific areas of memory to store each of these different things. So there'll be an area to store the item, an area to store the price, an area to store the amount, and so on. When it sets aside the area for tax rate, it's going to, well, actually, let me back up and just talk about this first. So what you should think about is you should think about variables as boxes in memory that hold values. I'm going to come back to that later. They're not, of course, literally boxes. What they are is parts of the chip. And things are not stored in terms of putting something in a box. They're stored by what current runs through the chip in different places. But as far as we're concerned as programmers, think of every variable as a box that can hold things, and the boxes have names: item, price, amount, and subtotal. Tax rate is not only given a name and not only is a box, but we put something in the box right away, 0.063, and then the other two are just sitting here. So this is what variables does. It sets up 7 specified named areas in memory that we can use, and we're going to think of them as 7 different boxes. Okay. Then there were 3 input statements at the beginning of the program. Now, what happened was when the program first runs, it doesn't do anything at all because an input statement just simply waits at first. And then the user hopefully was smart enough to know, or somehow was in the know enough to know what to do. So the user types in the things we want. We want an item name of an item like milk, and then a price like $2.25 per gallon, and then an amount like 2. So let's suppose he types in those 3 things: milk, $2.25, and 2. Now the computer springs into operation. The program springs into operation. It takes each of those pieces of data and moves them into the variables in memory. The first item it takes, it puts into the first variable mentioned, item. So milk goes into item. The second item, $2.25, goes into price. The third item goes into amount. Okay, and so those 3 get filled up. The next three lines in the program were put statements. The first one says put price times amount and subtotal. That star there is the programming speak for times. There is no normal times key on the keyboard, so we just use star. So price times amount means take whatever's in price, $2.25, times whatever's in amount, 2, multiply it, get $4.50, and put that into subtotal. And similarly, put subtotal times tax rate in tax, we'll put 0.2835 in tax. And then put tax plus subtotal in total, we'll put tax plus the subtotal back into total here. And that's what that will do. And then finally, we have to output it. So that's the phrase output total. That just says take total and send it to the output device. So on the output device, it'll take 4.78. Now, there's a detail here that we'll talk more about later. You might think this should say 4.7835, and that would be completely accurate in many ways because that's what's actually stored in total. But one of the things that you'll do in a real programming language is you'll try to format your output properly. And since this is dollars and cents, it should probably be formatted as 4.78, not 4.7835. Well, in our class, I'm trying to avoid dealing with formatting output because it's not very helpful for what we're focusing on. So in our class, we have telepathic computers. And when you put an output statement is, they telepathically know what you want for the format of the output. They won't guess what answer you want, but they'll guess what the format is. And so we'll just assume that it automatically prints it out as 4.78 instead of 4.7835. Don't worry about it too much. That's the whole point, is you don't have to worry about it. When we get to an actual programming language next semester, then I'll show you how you can add formatting statements that affect that. All right, so if you look at what's going on over the last 3 slides, it's all about shuffling data around. We start by taking data that came in from the keyboard and put it into the variables. Then we shuffle some more data around, calculating as we go, and put it in more variables. And then we take one of those variables and shuffle data from there over to the output. So everything's moving data around. In this case, we did some input first and then some put statements and then an output statement, but sometimes you could go back and forth between the two. Do some input again and then go back and do another output and then go back and do some more puts and then another output or something like that. Okay, back to the statements we're looking at. We have 4 types of statements. I want to focus just on the first 2. Variable declarations first. So here's our variable declarations from this example. Here's the thing I said before. A variable, for our purposes, is a box that holds a value. So here's amount and here's item. Think of them as boxes. An amount has like a 2 in it, or we could have put a 3 in it. An item has like the word milk in it, or we could have put the word eggs in it, or whatever else you want to put in it. The point is, it's a box that holds a value, and each box has a name. So the box on the left has the value 3 and the name amount. The box on the right has the value eggs and the name item. And there are rules for what variable names can be, and we'll talk about those in a few minutes. Each box also has a type. That is, boxes hold different types of things. Some boxes in our case hold strings, and some boxes in our case hold numbers. You can tell that in the variable declarations, because if they hold strings, they say string at the beginning, and if they hold numbers, they say num at the beginning for numeric type. So this says that item is expected to hold whole words like eggs or milk, text, but amount is expected only to hold numbers. And if you try to put a word like milk into a variable like amount, which is numeric, it'll crash the program. And if you try to put 3 into an item that's a string, it'll probably crash it also, although there's some ways you can convert it to a string. So that's the way that works. Not only do we have those things, but also some of the variables can be initialized. So here we've got tax rate, and in the variable declarations, I say it's equal to 0.6063, so that actually sets it up with an initial value. That's called initializing the variable. Now, the important thing to know is that if you have uninitialized variables, like this, amount and item, where there's no initialization given in the variable declarations, they are not empty. Amount and item are locations in memory, and memory is never empty. It's always got something in it. So they actually have something in them. And it could be 0, but it probably won't be. It'll actually be whatever was in there randomly from the last program that ran. So if you have an uninitialized variable, it's not 0, it's not empty, it's simply undefined. That is, it could be anything. And the way I'll draw it usually, if I bother to, will be to put question marks in there. So you need to think that every one of these except tax rate starts with a question mark in it. That is, it could have anything at all in it. Really good, really bad. It didn't really helpful for you, really unhelpful for you, but it just has something. So one of your goals as a programmer is to make sure that you never use that random amount value in something. You always actually first put something in it that you want to have in it. Okay, you initialize all your variables somehow. Okay, there's a couple rules for the variables. As far as names for variables are either letters or numbers, and they have to start with a letter. So you can have like price or amount or item, or even item 1 or item 2, but not one item or 2 item, because that's to start with a letter. Everything has to be only letters and numbers. So if you have 2 words together, like tax rate, you have to squish them together, like tax rate with no space. If you put a space, it's wrong. It's case insensitive for our class. So if you put tax rate with a capital R or tax rate with a small r, it'll think you're talking about the same variable. In C++, which we do next semester, it's case sensitive. So if you have tax rate with a small r and another variable called tax rate with a capital R, it'll think it's 2 different variables. Now, I wouldn't suggest doing that because it'll just make it confusing, but that's what it would mean. But in this case, it's case insensitive. By the way, most of the time people actually do capitalize them in a way which makes things clear. So they often capitalize the first letter of every word, or they do what I did up there with the tax rate. They capitalize only the first letter of every word after the first word. What that's sometimes called camel case, because it looks like there's a hump in the middle. And it's just an easier way to see things. The main thing to know is that variable names need to be understandable. So in math, variables are usually given names like X, Y, Z, A, B, C. But here we want them to be given names that are whole words so that you understand what each thing is. You don't want to say, what is X again? I forgot what it's holding. So you want to name things like price and amount and so on. Don't get ridiculous. You don't have to call it the price that the user is entering so that I can solve the program. You can just call it price. But make sure that any variable name you look at it's immediately obvious what it's talking about. And I will pull points off if you use variable names that are too meaningless or too short. That's just part of good programming style. By the way, again, remember that in math, you think of variables as unknowns, as values that just change. But here we're thinking of variables as boxes with names and contents. All right. Types. For us, so far, we've looked at two types. Numeric or num types hold numbers, and string holds text of some kind. Eventually, if you get into C++, you'll eventually get a whole bunch more types, including more than one numeric type. There'll be some that have decimal parts and some that don't, for example. Some that are bigger than others. So for us, we're just going to use these two primarily, and then I'll add a few more types as we go through the semester, and you'll see those as we go along. By the way, if something doesn't act like a number, use a string, not a num type. So for example, obviously an address like 101 West Main that has numbers in it, but it's also got text in it. You can't really use a numeric variable for that, so just use a string. But social security numbers, it might surprise you. You should probably use a string for it rather than a number, because social security numbers, first of all, sometimes they have dashes, but secondly, some social security numbers start with 0. If a social security number starts with 0, you want to print the 0 when you print it, and if it was a number, it would leave the 0 out at the beginning. But mainly, the giveaway is that social security numbers don't really act like numbers. You don't add them or subtract them or multiply them. You don't even compare to see which one's bigger. All you do is just simply use them as strings of symbols. And those symbols happen to be digits, but they could just as easily have been strings of letters, and social security numbers would work just as well. Same thing's true of phone numbers and zip codes. You don't really use those like numbers. So those should probably be strings. If you want to initialize a string variable, you include double quotes. So when we did initialize tax rate, we said equals 0.063 without any quotes at all. But if we'd wanted to initialize item to set it up to say milk right away, we'd have to actually put quote milk, close quote. And you'll see more about why later on. Okay. Then finally, let's talk about put statements a little bit. They'll be replaced by assignment statements next week. Not assignments statements, but assignment statements. They all look like this. Put something in something. And the first something is an expression of some kind, and the second thing is a variable. So for example, put 10 in amount. What that means is we've got a variable amount. We don't know what's in it so far, but we're going to put 10 in it. Or put price in amount. What that means is we have another variable price which already has something in it, like say 5, and this takes a copy of what's in price and puts it into amount, making it 5. Notice it copies it, doesn't move it out of price. Price still has 5 in it. And notice it doesn't matter what used to be an amount, it gets completely overwritten. Now you've got 5 in amount. Put price plus 2 in amount. We start with something in price like 5. We add price plus 2 to get 7, so it does a calculation first and then puts it into amount. You can have very complex calculations here. Price plus 2 times 3 divided by 5 times 7 or something. That's a strange calculation, but anyway. Put amount plus 1 in amount. This takes what's already in amount, the 7, adds 1 to it, getting 8, and puts that right back into amount. So basically, this just increases amount by 1. You can also put strings into string variables. So putting milk in item would do this. It would take item with whoever knows what in it and put milk in it instead. Notice that when you use the put statement, just like with the initialization, you put quotes around the word milk. Now, here you can see a little bit why you should do that. Why should you put quotes around the word milk? Why is that a part of our rules? Because if we didn't have a rule, milk would look like another variable name. I mean, look at the second line here, put price and amount. How does it know whether to put the word price and amount or the variable value? Well, the answer is you don't have quotes around it, so it assumes it's a variable. So anyway, this is how you deal with putting things into string variables. Okay, that's that. I will give you an example of using variables and put statements in a part of an assignment in another video, and then after that I'm going to do another video about input and output statements a little bit more and the second part of the assignment. So that's all coming soon.